Hi everyone. In this video I'm going to show you how to graph linear inequalities in two variables. And so that's just a fancy way of saying we're just going to graph lines the same way we did in Math 10 or Math 10C in Alberta or grade 9 math, where you actually just draw your linear equation using y equals mx plus b form as you usually would. And then just an extra step at the end of thinking about whether or not we care about the stuff above the line or below the line. So if you're comfortable with graphing lines, then this should be fairly straightforward. We're just adding one more step at the end. So first thing, this function in green, y is greater than or equal to half of x minus 3. Conveniently, I've given this to you in y equals mx plus b form. So we can just graph this as usual. Negative 3 is down here. A half x means that it's rise of 1, run of 2. So up 1 over 2, up 1 over 2, up 1 over 2, right? And then backwards is down 1, back 2, down 1, back 2. Hopefully you're pretty confident with graphing y equals mx plus b lines. And so we're just going to graph this line as usual. And one thing that does make it a little bit different is we're going to either do a solid line for greater than or equal to or less than or equal to. And in our next example, it's just a less than symbol. So we're going to do a dotted line for greater thans or less thans. And so the solid line means that points on the line are allowed because they are equal to the thing. Or dotted lines mean that points that are actually on the line are not allowed because they're not technically greater than or less than the equation. So in our green equation, it does include the points. They can be equal to, so we're going to just graph this as we usually would with a solid line. And the one thing we're going to add now is that we care about stuff that is above that line. So what we're going to do is we're going to shade in this region that is above our line. So if we sort of label this line here in green is the line y equals 1 half x minus 3. And this whole region is y is greater than or equal to 1 half x minus 3, if that makes sense. So the inequality is the region, and if we had changed it to an equation, then it would be a line, right? So the equal sign would be just the line itself. Okay, so let's try this equation in pink. First of all, it's not in y equals mx plus b form, so I suppose you could do your x-intercept, y-intercept method to figure it out, but that's really not convenient for an inequality. For an inequality, we really just want y is greater than something or y is less than something, so that we know, like, am I going to shade? Do I care about shading above the line or do I care about shading below the line? And it's not necessarily obvious if you just go to graph this using if you know it, the x-intercept, y-intercept method. So what I'm going to do is I'm going to do a little bit of algebra. I'm going to subtract 4x, so that I've got 2y is less than negative 4x plus 10. And I'm going to divide by 2. Now, addition, subtraction, you don't need to worry about, but when you're dividing, you need to be very, very careful. Am I dividing by a negative sign? And in this case, I'm not dividing by a negative sign, so it's okay. It's going to stay as less than. But if I was dividing by negative 2 here, you need to be very careful to then flip your inequality. Okay, so that's just sort of the one wrinkle just to keep in mind. In this case, it's just going to be negative 2x plus 5. So how do I graph that? Well, I'm going to graph my y-intercept is 1, 2, 3, 4, 5. So that's this point here. And because it is less than, the one difference is when I get to graphing the line, I'm going to use a dotted line, as I mentioned before. And the slope is negative 2, so over 1 down 2, over 1 down 2, over 1 down 2, over 1 down 2, right? So there is our slope of our line. And when I fill in my line, I'm going to fill in a dotted line. And that dotted line indicates that points on the line are not allowed because points on the line are equal to our equation, right? Our equation is y equals negative 2x plus 5, right? So our equation is y equals negative 2x plus 5. And we want y to be less than that. So we want the region that is below the line. And so that gives us this region here. And so you'll notice that this sort of section here, not quite a quadrant, but between that solid line and this dotted line gives us the intersection of these two inequalities. So that means that any point in here, like this point here, our origin, 0, 0, satisfies both of these inequalities. This point over here, this is negative 3 comma 5, satisfies both inequalities. This point over here is negative 1, 2, 3, 4, 5, 6, 7. So negative 7 comma negative 3 also satisfies both of our inequalities. So any point, like all these points that I'm filling in here, are all points, or even fractional points, decimal points, whatever. Those are all points that are in both the purple region and the dark green region, which represents solutions to both of our inequalities. Okay, so that is how you graph linear inequalities in two variables and how you actually find solutions to linear inequalities in two variables. Of course, as soon as I finished recording, I forgot a really important point. The idea of equality versus inequality we should talk about. This point here that's on the dotted line is not less than negative 2x plus 5. So this point would not be part of the solution. So because it's no good. Because we aren't allowed points that are on the dotted line. However, if we had a point right here that is exactly on the solid line, this green line, where it can be equal to, right? We are allowed to be equal to our half x minus 3. So since we're allowed to be equal to that, this point here at negative 2, negative 4, negative 2, negative 4 would be part of our solution. That one's cool because it's on the solid line. So again, solid lines, yes, they're allowed because you can be equal to it. Dotted lines are not allowed because you cannot be equal to them.